All right, guys, let's take a shot at another video. So this is chapter 1, section 6, page 1 of 1. Today we're hitting an old friend of ours, distributive property. Okay, you know the distributive property because I know you've had it since about the 6th grade. But I want to go back to why. Why does it work? Why is 3 times the sum of x and 4? Why is that equal to 3 times x plus 3 times 4? Because you got to understand the depth of the distributive property to really become effective at using it. Because see, the mistake most people make is they go 3 times x, but they forget the 3 times 4. To me, that's just a sign of a misunderstanding or not understanding deeply what the distributive property is all about. Okay, so what we're going to do is we're going to do this with a diagram, all right? So I'm going to create some boxes here. I think I can do it up here. All right, so I've got doing this, and then come down here a little bit. Probably wondering why I put those gaps in there, and I'll explain that in just a sec. Okay, so what I'm going to do is I'm going to put a break line in here. A break line looks like this, and maybe some of you have seen this before. Because what I'm going to do is define some boundaries for this box. I'm going to define this dimension as 3. I'm going to define this dimension as 4. That goes from there to there. But x, I don't know what x is. So if I put this break line in here, it just means that dimension is x. I don't really know how long it is, but that's a good representation of it. All right, now you remember how to find the area of a rectangle? The area of a rectangle is length times width. Okay, so if I wanted to find the area of this rectangle right here, that would be 3 times x. Width is 3, length is x, so this is 3x. And if I wanted to find the length or the area of this rectangle, that would be 3 times 4. So this is 3 times 4, right? You with me? Okay, well, another way to look at this is, and we'll draw this pretty much the same box here. Make sure I've got my all lined up. Right there. Like that. So there are the ends. Here's the break. But this time, instead of drawing a solid line right there, I'm going to draw a dashed line. Okay? Because I'm going to look at this dimension as a whole. This is x plus 4. This is still 3. So if I wanted to find the area of this overall rectangle, that would be 3 times x plus 4. So this area model kind of helps you understand why 3 times the sum of x and 4, this side, is the same as 3 times x plus 3 times 4, because we're just doing the multiplication of this width individually to the x and then to the 4. All right, so let's look at this algebraically, okay? So the distributive property, officially, this is what it says. It says if you have a number a outside the sum of 2 other numbers that we're calling b and c, then this is equal to ab plus ac. See, we distributed the a to the b and the c. Okay, well that also works. I can switch the order. I can put b and c, b plus c there, and a here. It still equals the same thing. It's still AB plus AC, okay? So I can put that single term out in front, or I can put it behind, but I get the same end result. Now, there's a kind of an opposite, if it distributive property in reverse, if you will. I can start with AB plus AC and do what's called factoring out. I can factor out, that's a terrible C, AC. I can factor out the A, that is in effect pull it out, and you get A times what's left over, which is B plus C. Okay, so you've got the distributive property and the distributive property in reverse. We don't really call it distributive property in reverse, but it's just a good way to describe what we're doing. Okay, so let's just take a look at some examples here. So we've got example tomato. And again, you try and figure out what the category for the examples is today. But let's just start with -2, and then in parentheses we've got m minus 3. Okay, it's a little bit different. I mean, up here I was doing all pluses, but you get the idea. Just down here you're going to have that minus, so you're going to have to be wary of that. But you take that -2, and you multiply it by both things in the parentheses. Sometimes it's 2 things, sometimes it's 3 things. Anyway, you're multiplying this number out front by everything inside the parentheses. So you've got -2 times m, and then you're going to go, I like to, well, you can do this anyway. I always revert to plus. Now you're probably wondering where the plus came from, but I always put plus, and then I go -2 times -3. So there are the negatives. -2 there, -3 there. I'm still accounting for all the negatives. I know a lot of you are already thinking a negative times a negative is a positive. That's fine. I mean, you deal with that, those details how you want to. Just make sure you're getting it right every time. So obviously, this becomes -2m. And like I said, a negative times a negative is a positive, so you've got plus 6. So very simple example of a distributive property. But I've got another one just because. So we've got example alphabet. I'll bet you know what the category is for today. So anyway, let's do something in reverse, distributive property in reverse, for example alphabet. So let's look at 12x plus 60. And we want to do what's called factoring this, okay? Well, one thing I notice is that both of these terms are divisible by 12. So I can think of this as 12 times x plus 12 times 5. Because 12 times 5 is 60. Well, notice that I've got a 12 in each term. So if I factor that out, then I've got 12 times what's left over, which is the x plus 5. So this is distributive property, and this is distributive property in reverse. Let's take a look at another one. Example, and we'll call this noodle. Have you figured out that the category for examples is types of soup? You got tomato soup, alphabet soup, and noodle soup. Okay, so this one, I like to give this example because this one generates a lot of mistakes down the road if you don't really kind of figure out what's going on here. And I've got 86 minus, let's just make it really weird. Let's put 9 pi, okay? So I've got negative, then the parentheses, 86 minus 9 pi. Well, if that negative is bothering you, rewrite the problem like this. -1 times 86 minus 9 pi. Now you have something to distribute. Now you know you're going to be distributing a -1 to both the things in the parentheses. So you've got -1 times 86 plus -1 times -9 pi equals, now -1 times 86, that's -86, plus a negative times a negative is a positive, and you've got 9 pi. So that's the solution to that one. We can do another example. Let's take a look at another example doing distributive property in reverse. And we'll throw a pi into this one just to make it different. Okay? So we've got 2 of 2. And we'll do example tortilla. Tortilla soup. All right. And this one I'm going to say is 12 pi plus 6x pi. Okay, now that's interesting, because not only do we have these pi terms, but I've also thrown in a variable x. So let's break this up, and let's recognize this as 6 times pi times 2. See, 6 pi times 2 is 12 pi. Plus, now notice there's already a 6 pi here. I'm just going to rearrange the terms. 6 pi times x. So I just rearranged the parts of this one. You can still, there's still a 6, there's still an x, and there's still a pi. Now we can factor out that 6 pi, and you've got 6 pi parenthesis 2 plus x. So these two terms are equivalent. We started with that, factored out the 6 pi, and we got that one. So just a quick reminder of what